So this problem right here is asking us to find the coordinates of point P on the circumference of our circle. We're given that my point P has rotated a value of 135 degrees. So I know in this case that theta is 135, and I also know that the radius of my circle from the center of the circle out to the edge is 4, unit of 4. So let's take that and let's put it instead on an XY axis. So if I come down here and I have my point P, which is out here at the end of this line, and I know that I am a distance of 4 from the center, and that theta is 135 degrees. Now, if we think about it instead in this XY Cartesian coordinate system instead of a circle, maybe we can apply what we were learning for our definition of trig functions. So it asks me to find the coordinates. Now remember, the coordinates of a point in our XY Cartesian coordinate system are given by an X coordinate along with a Y coordinate. So in other words, P is going to be defined by X and Y. So we want to take just a second and think about our definition of trig functions. Say that the sine of theta is equal to y over r, and the cosine of theta is equal to x over r. And what we're given in this particular problem is we know what theta is, it's at 135, and we know what r is. Remember, r is the distance from the center out to the edge of our circle. In fact, if I were to drop a line perpendicular down to the x-axis, you can see now that I have my right triangle here, where r is the hypotenuse of my triangle of 4, and it's the y and the x coordinates that I would be looking for. Okay, so we go back here, and you notice that I only talked about sine and cosine, even though there are 6 trig functions available. The reason for that is because in the definition of sine, we know theta, we know r, and we are looking to solve for y. So the sine definition gives me 2 out of the 3 values that I am looking for to be able to solve for the missing piece. Cosine also gives me a theta and an r, leaving me with only 1 missing piece to solve for. And if you were to go through and look at the remaining 4 trig function values, you'll see that sine and cosine are the best choices for us to be able to solve for y and x in this case. Now, what do we do with it from here? So I'm going to kind of fill in that the sine of 135 degrees. Remember, theta is 135 degrees. They gave it to me like that in the problem. That's equal to y divided by 4 because r is 4. Now we're going to apply our kind of reference angles, which is what we've been discussing in this chapter also. So let me get rid of my x and my y, kind of get rid of that right there. We know that 135 degrees is over here in the second quadrant, and so there must be a reference angle from the first quadrant that would help me identify the sine of 135. Well, this little bitty value right here that I just highlighted in blue, let me make that a little bigger, that little value right there is 180 degrees minus 135, which is 45 degrees. Remember, reference angles are acute angles that are only between 0 and 90 degrees. So 45 degrees is the reference angle for 135. Now, how does that help me? Well, hopefully you're memorizing the fact that the sine of 45 is going to be the square root of 2 over 2. But because sine of 135 is in the second quadrant, the sine of 135 would be positive square root of 2 over 2. Remember, sine is always going to be positive in the second quadrant. So hopefully you're getting, you're understanding the idea between reference angles and how we apply them. So if the sine of 135 degrees is the square root of 2 over 2, and that's equal to y divided by 4, I have a simple equation now here to solve. I'm going to multiply both sides by 4. This 4 reduces with that 2, leaving me with 2 square roots of 2 is equal to y. So let's see if we can do the same concept over here for cosine. The cosine of 135 degrees is equal to x divided by 4. Now cosine of 135, remember 45 is the reference angle that we are using over here in the first quadrant. And the cosine of 45 is positive square root of 2 over 2. But because we are really rotating all the way to the second quadrant, cosine is negative in the second quadrant. So for this problem, the cosine of 135 is negative square root of 2 over 2. That's equal to x divided by 4, and we have the same problem we did just a second ago. Multiply both sides by 4. The 4 and the 2 reduce, leaving me with negative 2 square roots of 2 equal to x. So the concept behind this problem is really twofold. Number one, take this idea that we have a point on a circle and really identify it more as a point in the Cartesian coordinate system, meaning I'm solving for x and y. Then you use your definition of trig functions to solve for the missing value, the y or the x. And the second part of that, I think, is the fact that you're applying your reference angles to angles that are moving around the rest of the unit circle. So hope that helps.